If you want the recording then. Okay, otherwise you can log in using the iPad, no problem. Okay. SAS with data types. In general, whenever we are trying to learn any database or any software, first of all, we must have an idea how that particular database or software will support different types of data. I mean to say, we are trying to learn the SAS. As we are trying to learn the SAS, we must have an idea how the SAS will behave with different types of data, like how it will behave with the character data, numerical data, date, etc. etc. Using SAS, we can work with the character data, numerical, as well as date also. Let me begin with numerical. I have a number 782. Now I want to read this number. In another word, I want to save this number. So either you want to read a number or you want to save a number using the SAS, then SAS occupies 8 byte of system memory. 8 byte is default, whatever may be the number it is. It may be a single digit number or it may be a multi-digit number. SAS occupies only 8 byte. It may be a single digit number, it will occupy 8 byte. Multi-digit number, 8 byte. Negative number, 8 byte. Floating number, 8 byte. So whatever it is, it may be a single digit number, multi-digit number, negative number, positive number, floating number, integer. Whatever it is, it occupies 8 byte. This is the nature of SAS regarding numbers. Okay. Let's think about behavior of SAS with character. Just 1 minute. So whatever may be the number, SAS occupies 8 byte of system memory. Now let us think about character. We have a person by the name Daniel. We have a person by the name Daniel. I want to read Daniel, or I want to save the name Daniel. If you are trying to read it or if you are trying to save it, we will get error. Why? Because by default SAS will expect everything as a number. The nature of SAS is it will treat everything as a number. But do actually Daniel is a number? No. It's a character. We know that it's a character, but the SAS doesn't know that it's a character. So if you want to specify this as a character, there we need the help of dollar sign. Dollar is used to declare the character data. Character, or we can also call it as text. By default, SAS cannot recognize the character, but if you want to declare it as a character, we need the help of dollar. So once we use dollar, then the SAS will identify it as a character and it will read it. But same thing, it will support only 8 byte, whether it may be a character or numerical, but especially when it comes to the character, it will occupy 1 byte for 1 character. It means maximum how many characters do the SAS will support? I said SAS will read 8 byte of data, and as I said, it will occupy 1 byte for 1 character. It means maximum how many characters do the SAS will read? 8 characters only. It will occupy 1 byte for 1 character. So I said 8 bytes. That means 8 characters. Suppose if I am trying to read Michael Jordan, how many characters or how many letters do we have for Michael Jordan? More than 8, isn't it? So if I'm trying to read it, it will support only 8. So it will read Michael J. And it will not read the remaining. Okay. You can say this is nothing but one kind of drawback or limitation which we have with the SAS. Okay. So there we need the help of length. Length class is used to declare the length for the data. If we use the length, we can extend the length of character up to maximum 2 gigabyte. By default, SAS will support only 8 byte of data, but once we use the length, we can extend the length of character up to maximum 2 GB. Okay. By default, SAS will support only 8 byte of data, but once we use the length, we can extend the length of character up to maximum 2 GB. Can you hear me? Hello?
Hello.
Yeah. You
Yeah,
are
we
with me,
can hear
right?
you. Yes.
Okay. So by default, SAS will support only 8 byte, but once I use the
Mm-hmm.
length, we can extend the length of character up to maximum 2 gigabyte.
Mm-hmm.
Up to that level, the SAS will support the characters. Now, let's think about date. Check out, we have a date value, January 10th, 1960. January 10th, 1960. Now I want to read this date. As I'm trying to read it, I got an error. Why? Because I already told you, SAS will expect everything as a
Mm-hmm.
number. But this is not a number. This is a date value. We know that this is nothing but a date. but the SAS doesn't know that it's nothing but a date. So if you want to declare this as a date, we need the help of InFormat. InFormat is used to read the date. Earlier I said $sign is used to read the character. In the similar way, InFormat is the keyword which is used to read the date. So once I gave InFormat, now the SAS will recognize this as a date and it will read it. But in SAS, dates are stored as numbers. In SAS, dates are stored as numbers. Now the question is how the SAS can store date as a number. What it will do is it will find out the difference between our given dates and the SAS default date as number of days. Here the SAS default date is January 1st, 1960. This is a constant date value which will never change. This is a constant date value which will never change. So whenever we have given a date, SAS will identify the difference between our given date and this date. And whatever may be the difference it got, it will store that value as the date value. Let me make it clear like this. This is the date which I am planning to store. And this is the default date of SAS. Now how many days of difference is there in between these two dates? 9 days. So it will store it as 9. January 10th, 1960 will be stored as number 9, or number 9 represents January 10th, 1960. And at the same time, if we have any date value before to the 1960, even in that situation also, it will find out the difference, but it will store it as a negative number. So this is the center figure. So based on this, SAS will always try to store the date. So when we have given a date, SAS will check whether our given date is before to the January 1st, 1960 or after to the January 1st, 1960. Suppose if our given date is before to the January 1st, 1960, it will identify the difference as number of days and it will store it as a negative number. If it is after to the January 1st, 1960, it will find out the difference as number of days and it will store it as a positive number. Okay? But here the problem is we are giving a pure date and the SAS is trying to show it as a number. So if you want to display it as it is, there we need the help of format. Format is used to write the date. Format is used to write the date. Once we gave the format, now the SAS will read it and it will display it in a normal way, in whatever style you want to display. Do you want to display it in the same style as I wrote it here? It will display in that way. Or if you want to display it in American format, where we used to have month in the first place, date in the middle, year at the ending, and whatever style you want to have it will be decided by the format. So in format is for reading and format is for writing. Okay. So let's see the examples for everything. This is the SAS icon. As a double click on the SAS icon, it opens the SAS environment. Check out SAS is a combination of different windows. On the left we have Explorer. In the center top we have Log. In the center bottom we have Editor. So we have different windows. So what are these windows and what is the use of each and every window? I will explain later, but before that I just want to show you the behavior of SAS with different types of data. So let's begin explaining the nature of SAS by creating a table. Check out on the left side top corner we have libraries. Libraries means nothing but SAS folders. Libraries means nothing but SAS folders. As I opened it, how many folders do we have right now? 4. In this 4 I will take work as the example. As I open the work, check out contents of work. Do we have anything in the work?
Nothing.
It's empty. We have nothing in the work. Now I want to create the table. So as I want to create the table, I will say data. In SAS, data means table. In SAS, data means table.
Okay.
And I said I want to have the table with the name A. I want to create the table by the name A.
Okay.
And we know that table is a combination of rows and columns. So I want to have a single column, nothing but sal. Input is used to declare the list of columns. Input is used to declare the list of columns. So I want to have a single column, nothing but sal. And chords is used to declare rows or records. Whatever you want to keep under the sal must be declared under the chords. Then finally I said run. Run means execute the program. Run means execute the program. So I submitted it. Run is for submission. As I submitted it, check out earlier there was no table, but now we got the table by the name A.
Yeah.
As I opened it, check out we have a single column sal. Check out we have a single column sal. And we have 4 rows. We have 4 rows. Whatever may be the number it is, it occupied 8 byte of length. It occupied 8 byte of length. This was okay. Now we have another table. Another table. I want to create another table B, where I want to have 3 columns: ID, name, sal. I said 101 Michael, 102 103. As I have 3 columns, I gave 3 values, and total I have given 3 records, and I said execute the program. Now I'm trying to submit it. Check out. Here we got B. As I opened it, check out, we have the table B. How many columns are there? Exactly 3 columns. But under ID we have 101, 102, 103. Under the salary we have 5,000, 3,000, 7,000. But do we have anything under the name?
No.
Well, because SAS is expecting name as a number. I already told you, by default SAS will expect everything as a number. But if you want to declare it as a character, what we have to do?
You can put the dollar sign.
We should give dollar. Remember that dollar should be given only in the input. Dollar must be given only in the input. That too after the name of the column. After the name of the column, not before the name. That means it must be given as a suffix but not as a prefix. I submitted it. Check out. Okay. Earlier it treated name as a number, but once I gave dollar, check out, it's treating name as a text, nothing but a character. Now let's say we have more than 8 characters. We have more than 8 characters. Now I'm trying to read it. As I'm trying to read it, check out. Here we have D. Okay. It read only 8 letters. I already told you by default it will read only 8. So if you want to overcome that, we have to declare the length. So I'm trying to declare the length. I'm trying to declare the length for which column? Is it for the ID or
Name.
is it for the name or is it for the salary?
For name.
It's for the name, and it's a character, so we have to give dollar. Then we have to declare how many letters do that name has. Here we have three names. The longest one is Michael Jordan and it has 13 letters. So I declared the length of the longest. Okay. So I have submitted it. Check out. Now we have the complete name. Okay. Earlier we have only 8 letters, but now we have more than 8 letters. Okay. We have date of birth 10th Jan 1960, 19th 16, 25th. I have given different date values here. As I'm trying to read it, check out, we got error. We got error. Why? Because SAS cannot read or identify dates. So if you want to read it, what we have to do? We should give in format. I will say in format as a date 9 dot. Date 9 dot. Date indicates it as a date value. 9 indicates, okay, the total width. The total width. So we have 2 for date, 3 for month, 4 for year. So the total width is 9. Check out. I already told you in SAS dates are stored as number of days from January 1st, 1960. So the difference between our given date and the SAS default date as number of days. Check out January 10th, 1960 and January 1st, 1960. The difference is 9 days. Today and the default date is 20,807 days. Difference between December 25th, 1959 and January 1st, 1960 is minus 7 days. Why? Because it is before to the January 1st, 1960. But if it is trying to show the date like this, all may get confused. Why? Because we are giving a pure date and the SAS is trying to show it as a number. That's why to overcome that problem, we need the help of format. So in format will help the SAS to read it, whereas format will help the SAS to write it. So as I gave format, check out. In whatever style I wrote it here, it's trying to display in the same style. Check out, it's internally number only. As we gave in format and format, SAS was able to read and write. Okay. Suppose if you are not interested to display in the same way, there I will say like this. Date in the first place, month in the middle, year at the ending, with 10 digits including the slash. Month in the first place, date in the middle, year at the ending. Okay. Or year in the first place, month in the middle, date at the ending. So it's completely our wish how you want to show the date. Or if you want to have it in a different style, you can even decide that. I'll say word. Instead of having the month with only 3 letters, I want to have the month with full form. If you want to have along with the week, Monday, Tuesday, then we can get it even in that style. Okay. All this is nothing but behavior of SAS with different types of data. Remember that SAS is case insensitive. If you want, we can write the program either in lowercase, or if you want, we can write it in uppercase. If you want, we can write it in mixed case. It doesn't matter. It may be in lowercase, uppercase, or it can be mixed case. Okay. And every programming statement must end with a semicolon. Every programming statement must end with a semicolon. Okay. Don't get confused. These are not programming statements. That's why we don't have semicolons here. Okay. And we should separate one value from another. Okay. Using space. Space as the separator. If you want to separate one value from another, we must separate it using space. In SAS, the default delimiter is space. And if you want, we can write the whole program within a single line. Or we can write it into number of lines. Okay, if you want, we can write the whole programming statement within a single line, or else we can write it into number of lines. So this is the nature of SAS with different types of data along with the programming rules. Okay, so this was the overview regarding the nature of SAS. I will stop here for today. If you have any questions, you can go.
I don't have any questions.
Okay. At the beginning, we will go a little bit slow until the software install and everything is okay. Once we started the programming part, automatically we will go for longer hours. Okay.
Okay, sure.
Okay then. Catch you tomorrow at the same time with same link. Okay. And I will just forward this code, whatever I wrote, to the training department. You can collect it from there. Okay. And I will send even the ebooks also to them. You can collect it from them. Okay. Okay then. Bye bye.
Okay, bye. See you.
Come again?
I'm saying bye.
Okay. Actually, your audio is not clear to me. Okay. If possible, try to join in the meeting using either laptop or desktop so that you can record the meeting. For today, I have recorded it. Okay, I will send it to you. Okay, from next time, if possible, try to use a system rather than iPod or something. Okay?
Yeah, okay, sure.
Okay then. Bye-bye.
Bye.